Hello folks, this is your first video lesson on points, lines, and planes. So after today, you'll be able to identify what these three things are and name them correctly with the proper notation. You'll be able to represent relationships among these points, lines, and planes, and then tell from a drawing what their intersection will be, okay? So let's just kind of talk a little bit what are points, lines, and planes. So point, line, and plane, hold on here, there we go. So unlike the real world objects that they model, points, lines, and planes do actually do not have a size. They're not finite, okay? So in geometry, points, lines, and planes are considered undefined terms because they are only explained using examples and descriptions. So I guess kind of in a way to think about it, they're kind of imaginary. Like we can think of things in real life that help us represent these things, but really they don't have a size. Does that kind of make sense? So like for a plane, for example, we sometimes say that a ceiling or a floor represented because it's a flat surface, but in actuality, a plane doesn't have an actual size. I know it's kind of hard to wrap your brain around, but we'll dig into it in a minute here. So our first undefined term is a point, okay? So a point is just a location. It has no shape or size. And we always use a capital letter to name it. So in this example here, one second here, folks. There we go. We call this point A. So there is our point right here. And that's how you would name it. So I have a capital letter that's next. So it's a point A. So again, it's just a location and it has no shape or size. Okay, now a line. Now we're getting a little bit, we're going to get gradually bigger, right? So a line is made up of points, okay? Any 2 points form a line. It has no thickness or width, and you can name a line by any 2 points on it, or the lowercase script letter. So in this example here, do you guys see how we have this little script letter right there? So you could call this line N, or you can use 2 points on lines, or you could call it line XY. And how you do that, you put XY, and then since it's a line, you put a little line on top. Or you could switch up the letters and do YX. Either way, all 3 of those are correct ways to name this line here. Some more vocab that we have is collinear. Collinear points lie on the same line. There we go. Non-collinear points would be points that don't lie on the same line. This is kind of an interesting little tidbit. I'd probably maybe underline this, highlight it. You must have 3 points for it to be potentially non-collinear, because through any 2 points you could draw a line. So what do I mean by that? So if I just have 2 random points, right? I can draw a line through that. It doesn't matter how wonky or whoa. Sorry, folks. New board. Lots of issues. Okay. You guys agree that I could draw a line through those points? Whereas if I have 3 points, I could maybe draw a line through them, or I might not be able to. Is that going to make sense? Okay. Let's go to the next one here. A plane. A plane is just a flat surface made up of points. Any 3 points make up a plane. So a plane extends indefinitely in all directions. And we name a plane by any 3 non-collinear points. So you guys underline that. They have to be non-collinear. Or you can use the uppercase script letter in the corner of the plane. So remember I said the plane's just a flat surface, right? So you could think of like the ceiling or floor or your desktop, right? Those would be considered planes. So if you wanted to name this plane up there, you would say plane P if you wanted to use that uppercase letter in the corner, or 3 non-collinear points in the plane, or you could have plane J, K, L, or any version of those letters in any order. You could have K, L, J, L, J, K, whatever. It doesn't matter the order as long as they're all inside your plane. Okay, so now these undefined terms can intersect. So if you have two lines that intersect, what kind of a figure do they form, or do they create? Well, they would make point P there, right? Line R and S intersect at point P, so they intersect at a point. Now this one's kind of tricky. Two planes, when they intersect, they actually form a line because all of these little individual points on there, you could connect and make a line. So two planes intersect at a line. All right, now we're just gonna name some stuff, folks, by using this diagram here. So it says use a diagram at right to name the following. 4 collinear points. Okay, now again, there's could be multiple answers for some of these. So if you worked ahead, you might have something different. But for this one, there is actually only one answer. There's only 4 collinear points. So collinear, remember, means on the same line. And that would have to be points H, N, K, and I. So points H, N, K, I. Name a line that contains point M. Here's point M. What line is it on? Well, it's on line P. Line P. Name a line that contains points H and K. Well, that's this line right here. So that could either be line R. You could call it line R. You could call it line HK, remember, with the little line on top, or any 2 points on that line. There's a couple different ways you can name it. Okay, that's good for now. Number D, it says, name another way for us to name line Q. Here's line Q, so pick any 2 points. Should be KL, KL, and then put the line on top, remember, you have to have that line on top. And then our last one, name the intersection of lines P and R. Where do P and R intersect? Well, let's trace them up quick here. P and R. Well, here's R. Here's P. And they intersect at point N. Perfect. Good work. Okay. Well, we'll finish this one up together in class tomorrow. So, thank you for watching. You guys have a super rest of your day, and I will see you in class.